Okay, on the grid, shade the region comprising all points whose coordinates satisfy the inequalities. Okay, so I'm going to start by getting rid of, sketch lines, and I would shade out, shade or hash really out, unwanted regions. So y equals 2x plus 5, so y equals 2x plus 5. We should be able to do that using y equals mx plus c. So we go to plus 5 and we've got a gradient of 2. So let's just check the scale. Yeah, that's all right. So 2 down, 1 across, 2 down, 1 across, 2 down, 1 across, 2 down, 1 across, 2 down, 1 across. There's our line going to go through there. You should use a ruler. It's a solid line because it's included in the wanted region. And we want the y values to be less, so we shade out, this is the unwanted region. Okay. So we also want 2y plus x is less than or equal to 6. So, quickest way probably on this one is just to put in values when x is 0. Whoops. When x is 0, y is 3. Just substituting it in our heads. When y is 0, x is 6. So you've got 6, 0, and 0, 3. So we can draw our line through there. Again, better if you use a ruler. That's not great, but you can see where the point should be. Perhaps I'll just try that again. Whoops. Okay, that's not much better, but anyway, there we go. So we want this time 2y plus x to be less than or equal to 6. So we want the lower value so we can shade out the bit above the line. Yeah, we want the lower bit. Yeah, we want this region, so we shade out the bit above. Y is greater than or equal to 2. So y equals 2 is here. So the line that goes across is here. And we want the values that are greater than or equal to 2. So we're going to shade out a bit. So our wanted region, label it clearly. They've said shade it. Is this bit in here? I could make the highlight pen smaller, but you can see what I'm getting at. That section in there. Part B, work out the shaded region. So we've got a triangle there. So we need the area of the base. So we need the points of intersection between the lines. So let's call these 1, 2, and 3. So intersection of 1 and 3 should be fairly easy because 3 is y equals 2. So we get 2 lots of 2 plus x equals 6, so x equals 4. 2 and 3 gives y equals 2, so we get 2 equals 2x plus 5, so minus 3 equals 2x. So x equals negative 3 over 2. So the base, which is the distance between, I'm taking as the distance between these two, is 4 take away negative 3 over 2, which is 11 over 2. Thinking of the 4 as 8 over 2. So we've got the base. Now for the height, we want the intersection between y equals 2x plus 5. So we're looking now for the intersection between 1 and 2, which is the lines y equals 2x plus 5, y equals 2x plus 5, and 2y plus x equals 6. 2y plus x equals 6. Well, I would tend to do this by substitution because we've got this y equals here, so we can just substitute it into there. So we get two lots. Now y is the same as 2x plus 5, so I've substituted that in, plus x equals 6, so we get 4x plus 10 plus x equals 6. Tidy it up, 3x equals, 5x, add collecting the x's, subtract the 10 minus 4, so x equals minus 4 over 5. Substitute it in to find y, so y is equal to 2 lots of minus 4 over 5 plus 5 equals minus 8 over 5 plus 25 over 5. So that gives us 17 over 5. So the height is equal to 17 over 5 minus 2, and we can think of that as minus 10 over 5, so that's 7 over 5. So the area is equal to, so the height we did by looking at the difference, in here. That was our height. So now the area is equal to 7 over 5 times, what was the base? 11 over 2 times a half. So we get 77 over 20 units squared.